Thanks, guys. So I'll be talking about the T20-ASV, and this is the new product we released end of last year. Before we go look at the ASV, just remind ourselves what the T20 looks like. Very compact, wet end, generate good data, but different types of processors, right? So you might remember we came out first with the PSP, portable solar processor, and IP rated 54, right? So what we're doing is we have enclosures around it, then it gets hot, so we need to have lots of fans inside, so that all means it gets needs lots of power, right? And then for USV environments, we want something that is that requires less power, less weight. So that's where we're coming from. We also have the rack mount, of course, with the integrated INS. So that's what we now have. So that's the T20-ASV processor. It's obviously much smaller, much lighter, and requires less power. Size-wise, it's about 30 by 15 by 20 centimeters, so kind of the size of a large lunchbox. And then optimized for power, but still having all the features that you're used to from a T20 or a SeaBat in general. So a couple of practical considerations we took when building this. First of all, if you think about cabling, I think about cabling inside a small vessel, right? The cables normally are quite thick. They don't bend very well. They have long connectors. So what we're doing now is we have just standard Amphenol connectors, and they're just wired straight. So within the vehicle, you just have the connector, the wiring going to a bulkhead connector. And that means that inside, you don't really have any bending radius to worry about. It's just the connector itself, and then we're talking about 15, 20 mil of the length of the connector. So that makes it easier. You notice the lifting points we have there. It's also easier to put that into the vehicle. If you ever try to maneuver around the vehicle, there's not a lot of space. Hard to get your arms around, so we have those lifting points for that. Then added benefit is also it stands off, so we have some protection for the connectors, and we have the airflow. So made it all much smaller. It's less than 6 kilos. We still have space for the GNS INS, so it comes with a IMU-20 or essentially a POS and V Wavemaster. And then there's some clever auto controls where if it loses power, it comes back up to life automatically, right? It remembers its settings, so it remembers your ping rate, any power gain settings, it remembers that. If you are recording, it continues recording, right? So also in that mind, we're thinking about what's practical about using a thing like this in an uncrewed, remote fashion. So when we're thinking about working remotely, there's more to it than just having a small unit or having something that's lightweight, less power, right? We also think about what is practical. We have a number of features that I just want to show you. They're certainly not new. We developed those a number of years ago now, improved it over the years with lots of feedback from the customers. And I think they're extremely suited for remote operations. And I just want to talk you through some of these. So first of all, the first one is called Tracker. The Tracker is like an autopilot, right? So it takes control of the sonar. So if you imagine, there are quite a few things to think about. You've got your range setting, your power, your gains, and such, and you don't really want to be babysitting the system in general, and certainly not if you're working in a remote fashion. So you want just the sonar to do that. So that's what Tracker does. It really is a very powerful autopilot. So what I'll show you now, when I start this video, first you just get lots of junk, right? Then you'll see that the user hits Tracker, and then it adjusts itself. So it starts adjusting the range, and then keep an eye out on, I don't think you can read that actually, but it will start changing things like power and gain, and so Tracker is in full control. See, yeah, there's just junk coming in, tracker gets turned on. It snaps to the right range immediately, right? And starts using the right power and gain settings. So the SeaBat increases, right? It will adjust the range automatically. If it runs into a low reflective SeaBat, it will start increasing the gain or your absorption or spreading as you wish. So that's done remotely. And again, thinking about remote surveying, right? This is a very, very powerful feature. The next special feature is our adaptive gates. We talk a lot about data quality, right? And nobody wants to be losing hours of their life killing dots. Nobody wants to be coming back to redo a survey, to do any fill-ins, right? So talk a lot about data quality, but really, from a sensor perspective, the receiver is low noise. We have really solid bomb detection. So from a sensor perspective, you shouldn't really get any noise. And if you do get noise, it can be just because you're using the wrong settings. So we got tracker for that. Then you always have situations where you maybe have some bubble wash, right? You got some wave action, right? And for those situations, you can use adaptive gates. With the adaptive gates, right? If you have these gates, those are the yellow lines, and it follows the SeaBat. So when we think about noise, really, it's not just really the sensor, it's also just how things are being operated and what circumstances you collect the data. So with adaptive gates, you can really reduce any noise you would otherwise be seeing. So in this clip, let me just start it for you. You're seeing here a flat SeaBat, key wall, right? And it kind of shows you quite a special case. You can imagine a flat SeaBat is easy enough to follow, right? We have a vertical structure, it becomes harder. And here we even have that vertical structure moving away from us. And then, but the gates, so those are the yellow lines, it still follows that. So it's, again, a very powerful tool to use when you're working in a remote fashion. The next one I want to talk about is normalized backscatter. Maybe in the first instance not so obvious why we want to talk about that from a remote perspective, but I'll come back to that in a moment. And sometimes I notice some apprehension from our users when it comes to collecting data from for backscatter. And that is because what they don't want is they don't want to see any changes in the final mosaic because the operator was changing the settings again, your power, your gain, your absorption, etc. But that's not necessary. That's not necessary with normalized backscatter. With normalized backscatter, we correct for those settings in real time. So what I've done here is I did a survey, I was running back and forth, and every line I changed some settings. I changed the power, changed the gain, changed absorption. And as you can see already that within lines, there's not really a difference in backscatter, right? You don't see where the operator was influencing it. So that's thanks to the normalized backscatter. Now you might notice there's an area here, for example, that doesn't look right. That doesn't look right. And what happened here is I just increased the gain, but I increased the gain really, really too far, right? And it goes beyond the dynamic range of the system. So that just means it's amplifying the signal so much the system can't measure that anymore. So that's why it looks so bad. What your Multibeam will then do is it will send an alarm and say, hey, you're in saturation mode. So that it will tell you, the user, that you have to change the settings. And you see the same there. So that's just to demonstrate the usefulness of normalized backscatter. But again, better yet is to use tracker. Use tracker to run the bathymetry and the backscatter, right? You don't need to worry about this. It just runs it for you. And the next example shows that. So here we're going, just have the bathy, we're sailing down the slope. This is roughly 15 to 30 meters, so reasonable slope there. And we have tracker enabled, and we're looking at the snippets data. And this is what lots of users don't want, right? This is why they might not want to use tracker, but this is what they're afraid of, that this happens. So you see all the different levels of backscatter, and that's because tracker was changing power, the gain, absorption, spreading, and changing that all the time. You can see it very well near the end, right? We're coming into deeper water, it's probably lower response, right? The system thinks, oh, I need to increase the gains, I need to amplify the signal more, and then it starts doing that. Here you can see it, there's lots of change. So this is what you don't want, right? But it works very well if you kind of combine, if you can combine tracker and normalized backscatter together, right? We don't need to worry about that. We don't need to worry about changes in the settings. The backscatter is collected and it looks the same. And this is what I mean from why this is a really powerful feature for remote operations, right? It's really hands-off. It's hands-off. You think you have a USV working there, you have a guy probably driving it, maybe it drives by itself, right? You don't want to be tinkering with the system. You don't want to be babysitting the system. You just want to collect the data and then trust that it's collected properly, right? And you can do that with tools like tracker and normalized backscatter. So when we think about multibeam surveying for small vehicles, right? There's a lot more to it than just size and weight. We're going to think about our swath coverage, right? With the T20, we can go up to 170 degree swath coverage. We're going to think about what's practical and which automation features we have that makes it much easier to use with 1024 beams. So there's more to it than just size and weight. There's also how practical is your system to use and to collect the data in a reasonable time. So where could you find the ASV? Well, we have it in our Z-boat. This is if you're familiar with the Z-boat, we have these well inserts, which before we used to have a single beam or a MB2. We now have a well insert for the T20. It's really easy to switch that. It takes you 10-20 minutes to take one insert out, put the other one in. So that's the T20. This is where then the processor sits. And that's on our Z-boat. So where else could you find it? We have seafloor systems. Maritime Robotics use our system. So we offer this system as a OEM product for the system integrators to use. We have it such that everything is already talking to each other, so it's easy to use. You turn it on, you don't need to worry about interfacing, let's say a POSM-V or such. That's already done for you. Maritime Robotics and seafloor systems, they're also here. If you want to see the T20 tomorrow, cabin 2 at 10 and 2 o'clock, Maritime Robotics is showing the T20. If you want to see the T50, seafloor systems is demonstrating that on Wednesdays at 1 o'clock. And we're also demonstrating the Z-boat with the T20-ASV on 10:30 on Wednesday and Thursday. So, just a quick overview. So T20-ASV, familiar product, the T20, different processor, still has the same capability, right? So it's power optimized, but you can still have all the features that you're familiar with. It still goes down to about 400 meters water depth. So if you think about, very shallow operations and down to 400 meters, that's a lot of area to cover. Has the automated features, has the SeaBat data quality, normalized backscatter. And I didn't mention that, but a 2 terabyte solid state drive as well for all your storage. Right, that's me. Guys, thanks for the information. If there are any questions, I can take them now, or we can take them later.
Teledyne Marine. Everywhere you look.